All right, everybody. Thanks so much for joining us for our second session of Sci-Fi Explained. Last week we did Interstellar, and this week we're going to tackle the movie Contact from the late 90s, I think. I think it was 97 when it came out. Also with Matthew McConaughey. So although he didn't get to travel in the wormhole in the movie Contact, he had a part in it. So he finally got his wormhole experience in Interstellar, like we saw last week. And I was just thinking about it. Maybe we should try to do only sci-fi movies with Matthew McConaughey. There have got to be some others.
We're going to say sci-fi movies with wormholes, but either way.
Or just, yeah, sci-fi movies with wormholes will be easy. I don't know if there's another sci-fi movie with Matthew McConaughey.
Maybe not.
maybe there is. I'm going to look into it. But let me share my screen with you, and we'll start off by watching the trailer just to refresh everyone's memory if you haven't seen the movie recently, and then we'll dive in. All right. Hopefully you can see the screen now. And here we go.
Of an unidentified radio source from deep space can neither be confirmed nor denied.
Whatever it is, it ain't local.
Position?
I checked interferometry somewhere in Lyra, I think.
Vega?
Can't be. It's only 26 light years away.
I want all these people out of here. Your having sent this announcement all over the world may well constitute a breach of national security.
Well, this isn't a person-to-person call. This may be an announcement to get our attention.
The president's called an emergency meeting.
You know those interlaced frames that we thought were noise? This has structure.
I'm going to recommend to the president that we militarize this project immediately.
There's no reason to believe that their intentions are hostile.
There's no proof of that.
Why don't they just speak English?
Mathematics is the only truly universal language, Senator. Buried within the message itself is the key to decoding it.
Those look like engineering schematics, almost like blueprints.
It is our belief that the message contains instructions for building some kind of machine.
A machine?
It might turn out to be some kind of a transport.
Transport? The fact is, you don't know what it does. It could be anything.
Nobody's saying this isn't dangerous.
They're gonna build it.
Who gets to go?
It's complicated, Ellie.
Who gets to go?
By doing this, you're willing to risk your life. You're willing to give your life and die for this. Why?
Okay. Spoiler alert, we haven't contacted aliens yet. So that's not what we're going to talk about.
One of the great challenges in this world.
There's Neil deGrasse
is knowing-
Tyson. We'll stop him right now. Hopefully he'll get his cameo in a sci-fi movie sometime soon. I think that'd be pretty good. So let me give you a little overview of some of the things that I want to talk about with the movie Contact. And then if there's any stuff that I don't mention in the outline here, we can add it in if you've got an interest. So first thing we have to talk about is the signals that actually get received in the movie. Is it plausible at all that the way they receive the signals are actually going to be the way that we potentially someday receive signals from some other form of intelligent life? So we'll talk about the signals. We have to talk about the star Vega. That's the location in space that the signals come from in the movie. Again, wormholes, just like last week. Wormholes play a prominent part near the end of the movie, so we'll tackle wormholes a bit more. And then we need to talk about a couple locations that are shown in the movie. The Arecibo Observatory in Puerto Rico, as well as the Very Large Array of telescopes in New Mexico. And both of those are pictured prominently in the film. The other thing that I want to talk about is just how the machine actually works that they receive plans for and somehow construct and then get to operate, which I think is all pretty interesting. But I want to start actually with the first few moments of the film because it's a really cool sequence, just about 30 seconds long. Shows us this incredible zoom from the Earth out past the Milky Way Galaxy, and contains a lot of interesting tidbits, some of which are good science, other parts are mere science fiction. So we'll start with that in just a minute, but were there any other things that folks wanted me to touch on that I didn't mention in that list that I gave there?
Well, I think you can add to it, even though you just touched on it and dispatched it, I want to bring it back in, which is the whole alien issue and how they, and why they portrayed it both the way they did, with the actual alien contact, wherever it was, and the narrative with it. Part of the narrative was we didn't create this system. It was here from when we got here.
Right.
And, so, and I guess with the first part where you're going to go, the narrative is going out from Earth. The very beginning of the 30 seconds is coming in to Earth first.
That's right. Yeah, the very first couple moments. Yeah, and we'll see that in just a sec. But yeah, we will definitely talk about aliens. And yeah, I wanted to mention. I mentioned that we haven't come in contact with aliens yet, but there are real attempts to come in contact with aliens, and in fact, this story is based on the real life people who do that. So we're definitely going to talk about SETI, the search for extraterrestrial intelligence, especially because we actually had the real life character that's portrayed in this book come and visit and give a talk for the Science Speaker Series a couple years ago. So we'll get to Jill Tarter and SETI later on. Let me. I actually got the movie here. I'm going to play the first few seconds for us. If I can figure out how to do this. Hopefully my dog will leave us alone in a moment. Can you guys see that new screen?
Yes.
Excellent. All right. So yeah, I think we're just going to play the first, I think it's about 35 seconds or so.
A date which will live in...
And we continue the season's final edition of our Maxwell House Good News of 1930.
Walter Winchell. Good evening, Mr. North American. All the ships at sea. Let's go to press.
Really?
Pillars of creation there in the Eagle Nebula.
You're that close?
Well, not exactly.
Yeah.
You know, we've zoomed out over 1,000 light years now.
Oh.
So now we're outside the entire Milky Way. Small Magellanic Cloud, or potentially the Large Magellanic Cloud, I'm not sure which. And now we're going through another galaxy. I think it's Centaurus A. I'm going to pause it there. And so a lot happens in that sequence. And there are some things that are true to the science as we know it in terms of how radio signals and TV signals leave the Earth. And there are some parts of it that are just totally bogus. So first of all, only some radio signals and TV signals actually can get past the ionosphere of Earth. All AM radio and other similar frequencies bounce off the ionosphere and never make it out into space. But FM radio and TV signals do actually pass through the ionosphere and travel out through space at the speed of light. And so what was depicted there is that as we traveled farther and farther away from Earth, we were listening to signals that had left farther back into the past. And the sequence is not actually correct if you really break it down through all those different radio broadcasts. They jumbled up the 70s and 80s and 60s, but it sounded nice. So those signals are traveling out at the speed of light, but they don't actually travel out intact in the way we just heard them at the same volume. Light waves, as well as all other waves in the electromagnetic spectrum, spread out as they travel away from a point source, whether that be from a star or from a radio or TV antenna. So I'm going to show you what I'm talking about there. Oh, that's not the right one. Hang on 1 second. See, I don't think you guys can see that image yet, right? Okay.
No.
I'm going to bring that up for you here. I think you should be able to see it now. We'll make it a little bit smaller. So the idea being that these waves spread out as they move away from the source from which they're emanating. And so I know it's a little tricky to see here. I can't quite get the right zoom on this. But signals really do travel out at the speed of light. And so, you know, if a signal left Earth 50 years ago, it really does travel 50 light years away in that time. But as it travels, it also spreads out and becomes much more diffuse because of what's called the inverse square law. And I want to show you an image of that as well, just so you know what I'm talking about. I got to bring up a new share so you can see that. I think you should be able to see that now.
Mm-hmm.
So as a signal spreads through space, it actually decreases in amplitude by the square of the distance. So when it's 2 times farther away, it's only 1/4 as strong, so on and so forth as it leaves its source. And so signals that have gone just 1 or 2 light years in the amplitude that they're actually currently being created on Earth through TV and radio, after about 2 light years, they're indistinguishable from noise. It's just the background radiation streaming through the universe. And that's with our current technology that we have on Earth. So yes, our signals do travel through space, and they've been streaming through space for almost 100 years now. But unless some intelligent civilization out there has the most radically advanced radio antennas that you can possibly imagine, there's almost no way that they're picking up the just random radio and TV signals that we're sending out. It would just get lost in the noise of space with all the other radiation streaming through space from stars and any type of cosmic event you can imagine. So it's a bit of a stretch that these intelligent life forms portrayed in the movie Contact were able to intercept the very first TV signal that was sent from Earth in the same way that it left Earth. It would have been so spread out that it would have been very, very difficult for them to find at all, let alone capture in any way that they could make sense out of. But we have to, suspend belief in that way, because maybe they were so radically advanced that they could, in fact, do that. So that's what we have to believe for this to make sense in the movie Contact. Vega, as mentioned in the trailer, is 26 light years away. So 13 times farther than technology on Earth today could capture any type of intelligible radio signal or TV signal. So yeah, the technology they would have had would need to be incredibly far advanced. But since they figured out how to open up a wormhole, maybe that's a technology that they had. But those are the facts in terms of radio signals moving away from the Earth. I want to show you how far they actually have traveled in the last 100 years relative to the Milky Way Galaxy. And this really gives you a sense of just how big the Milky Way Galaxy is and just how small of a distance our reach is. So here's a computer-generated image of the Milky Way. We're out in the Sagittarius arm over here, and this tiny little green dots in the inset here, 200 light years in diameter, is the full extent of the first radio signals and TV signals that left the Earth. So as you can see, a barely perceptible space in the Milky Way Galaxy. However, if there is sufficiently advanced civilizations within that 200 light year bubble that have the technology to pick out almost imperceptible radio signals in the background of radiation through space, maybe they do know that we're here. And they're hearing, some signals that left Earth a long time ago, depending on how far away they are. If they're 50 light years away from us, they're hearing the signals that left here 50 years ago. If they're 100 light years away, they're hearing the signals from 100 years. Yeah, Stuart.
Actually, it's Deb. Deb. Where is Vega on that depiction?
It's near the center of that little green dot, only 26 light years away from us. And so they did, Carl Sagan, who wrote the book Contact that the screenplay is based off of,
Yes.
he's a super smart guy. So he picked a prominent star in the sky that, most amateur astronomers at the time would have known about. It's the 5th brightest star in the sky, 3rd brightest in the northern hemisphere, and a star of the proper distance to make work in this storyline. So in the story, the TV signals that get picked up by this intelligent life form on a planet around Vega are the very first TV signals that left Earth, which happened to be Hitler presiding over the 1936 Berlin Olympic Games. So you take the time from 1936, 25 years for those signals to get to Vega, some amount of time for those signals to be encoded with the information that gets sent back by those intelligent life forms, and then another 25, 26 years for those signals to return to Earth. The early 90s is the correct time for that to all take place, as it does in the movie and in the book as well. I think the book was set to the year 2000, so provided a bit more time for that intelligent life form to embed their signals and send it back to Earth. So yeah, well within that 200 light year bubble, just 25 and a half light years away. And so speaking of the star Vega, at the time Carl Sagan was writing this book, and at the time the movie was made, there had only been one exosolar planet discovered by the late 90s. And it wasn't around the star Vega. It was a star in the constellation Boötes, not too far in the sky from Lyra, the constellation that Vega was in. But at that time, nobody had any idea whether there were many more planets out there. Since then, we've discovered at least 4,000 stars in the Milky Way Galaxy, all within this close area, all within a few thousand light years of Earth, that actually do have planets, Vega included. We've actually discovered a Neptune-size gas giant planet around Vega, and also a very, very large asteroid field. It may be something more like the Kuiper Belt that we have on Earth, which is where short period comets come from. Basically an asteroid belt beyond the orbit of Pluto. So there may be rocky planets closer into Vega. They haven't been discovered yet, but we know that there's at least one planet and some huge disk of dust and gas that's either in the process of forming new planets or is the leftover remains of potential planetary collisions. We don't really know which yet. We just don't have the technology to see that kind of detail into that debris field around Vega. But the James Webb Space Telescope will have those capabilities. So in the next few years, we may actually identify terrestrial.
That thing has been put off and put off. When is the current date now for the James Webb?
Yeah, great question. I think right now we're looking at 2024 for a launch date. Originally it was 2018. I'm really happy with NASA taking their time because unlike with the Hubble Space Telescope, if there's anything wrong with the mirror on James Webb, that's it. It's going 4 million miles out. And so, excuse me, 1 million miles out, 4 times the distance to the moon. And so if there's anything that breaks on it, that's it. It's just dead in the water. So NASA is doing...
Unless you can fix it with software updates. Hardware.
Sure. If it's a software problem, yeah, that can be correctable. But if there's anything wrong with the hardware, there's probably very little they'll be able to do. So yeah, in 2024, we might actually get some pictures of terrestrial planets around Vega. Carl Sagan actually died during the making of Contact. So he never got to live to see the incredible number of exosolar planets that have been discovered. I can only imagine how excited he would have been to know that lots of stars, and including Vega, actually had planets going around them.
You do get the feeling from that first, what came to my mind when you showed that was his whole concept of the pale blue dot.
Yeah, definitely.
That in that beginning sequence.
Yeah, so for those of you who are unfamiliar with the pale blue dot, it's probably one of the most famous pictures of Earth ever taken. Was taken by one of the Voyager spacecraft. as it passed the orbit of Neptune. The spacecraft turned around and took a portrait of the solar system. It pointed to all the different locations of the planets and captured the relative positions of the planets in a single frame. Each planet in one frame, and then stacked them all together to show the orientation of all the planets. It's the only portrait of the solar system that's ever been taken. And for a while, the scientists who were getting these images couldn't find Earth. Finally, someone happened to be looking at a sunbeam through one of the frames taken, thought to be the position of Earth, and this tiny, tiny little blue dot was right embedded into this sunbeam. And that turned out to be Earth. And Carl Sagan became famous during that time very quickly for his commentary on all the images being sent back by Voyager, and his proclamation of the pale blue dot pictured by Voyager is no exception to that. Probably one of the coolest references to the Earth. So yeah, and speaking of the planets depicted in that opening scene, they're horribly out of sync. There's no way the planets can align themselves like that, as depicted in that opening scene, traveling in a straight line distance trajectory from Earth. It just doesn't happen. There are resonance with the planets, and so they just don't align themselves like that. And the spot on Jupiter is on the wrong location on the planet as well. But all of that makes for nice choreography for an opening scene to really give you an idea of the distance between the objects in the solar system. But those are the planets in the right order, but not in the right positions. So we've covered the radio signals. We talked about the star Vega. I want to show you a little bit about the two radio antennas that are shown in the movie that play a part both in receiving the signals and in the research being done by the main character in the movie, Ellie Airway. So let me see if I can bring that back up for us here. And try to go to the scene where the first of those radio antennas is shown. There it is. All right. So this is a real telescope. This is the Arecibo Observatory. I'm trying to find a better picture of it. Let's see here.
Is it James Bond?
Oh, there we go. There we go. What's that?
There's a James Bond movie that starts there.
Yes, it's been used in several movies, but this is the real deal.
I've been in this place.
You've been there?
Yeah, I've been there in Puerto Rico.
Yeah. Oh,
yeah.
Boy, I'm
and
jealous.
Me too. And Deb too.
Very cool.
Yeah.
So up until a few years ago, this was the biggest radio telescope in the world. The Chinese have actually built a larger one now that dwarfs this telescope. The acronym for the other radio telescope built by the Chinese is FAST. I can't remember what the acronym stands for right now, but I think it's over 3 times as large as this radio telescope. It's enormous. Built into a similar concavity in the landscape as this one. And it's really cool that they decided to use this telescope because SETI actually has done observing runs using the Arecibo telescope. So this is a real instrument that we've actually used to detect signals from intelligent civilizations. There's a really famous signal, I think received in the 1970s, called the WOW signal. And we now know that it came from a pulsar. But at the time, it was the closest thing to a detection of intelligent life that had been found. And I believe it was found using this instrument, Arecibo. So these were actually real shots taken at Arecibo. But that's not where they actually found the signals in this movie. They were at a very different set of telescopes in New Mexico, which just passed. There's a great shot of it. Backtrack a little bit here. That's a pretty good shot.
Her name, she was referred to as the high priestess of the desert.
You mean in the movie or the real Jill Tarter?
No, in I don't know about the real, but in the movie they referred to her that way at one point because of this.
Yeah. So it turns out that they actually did not do any filming at the VLA. At the time, it was being used to collect data, and so they couldn't go there. And so they recreated a mock-up of it in California. They didn't actually shoot on scene there. These telescopes do search for radio signals, but they don't search for sources of intelligent life. They're not capable of doing that. So that was kind of a stretch in the movie. Like I say, though, they can certainly search for radio sources. They can be used to find black holes, other objects that emit strong radio sources, but yeah, they're just not designed to find point sources like telltale signs of technological civilizations. The other interesting piece about the way they depicted this is a couple scenes later. Let me see if I can bring it up here. She's sitting in a canyon. Oh, there it is right there. This canyon does not exist by the VLA. It's a pretty flat landscape out there. And so this canyon scene, I think it's actually Canyon de Chelly, but nowhere near where the VLA is, but makes for a sentimental moment. Aliens. Actually, before we get to aliens, I want to show you the device. So the device they actually build is pretty spectacular.
Can we go back to can we go back to the signal itself that comes in and the breakdown of the signal?
Yeah, let me see if I can find a good image of it here. I think it's somewhere right in here. Yeah, here we go. So there's one image of it. Oh no, I missed it. Hang on. For some reason, the little cursor here is out of sync. Let's see if I can find another good image of it on the screen. No. Come on.
There
we go. Yeah, it keeps on bringing me to a slightly different yeah.
If you play it for a second, the video might.
Yeah, I can do that. Let's try that.
Oh, come on.
All right, so there are a couple different pieces going on here. So the first what they get is audio, right? They just get this like this pulsating audio signal, which really could be a slow pulsar or some other periodic event up in the cosmos. So they know it's a sky-based signal at this point, but then something miraculous happens, which totally confirms their suspicion that it's from an alien source. It starts pulsating prime numbers, right? So you get 1, 3, 5, 7, 11, so on and so forth. And they start keeping track of all these prime numbers. And I can't remember exactly how many prime numbers it goes through, but at least 1 to 100. And that's when they decide they have to call everybody, because there's no way that a natural source could actually be pulsating out prime numbers. But that's just the beginning. A little while later.
Then there was the argument that, the national security people kind of got critical of her for not keeping this within the country.
Right.
And he said, well, I had to get confirmation from all the other satellites. They showed the other outposts and they showed Australia.
Right.
So is that really, what about that?
Yeah,
does that
the
kind of,
Earth. The Earth.
Yeah,
so you needed that kind of confirmation from Australia?
Yeah, I mean, I think if there was any real-time signal coming in, I'll show you the telescopes that SETI actually uses for the most part to detect these signals. If they ever detected anything, they would surely call their partners in as many places as they could to see if they could also pick up the same signal, just to confirm that it wasn't something with instrumentation that they were experiencing. So yeah, you definitely want some kind of secondary and tertiary reading. The other thing that the reason they had to do that in the movie was that Vega's only up in the sky for a certain amount of time, and then Vega sets in the northern hemisphere. So they needed someone in the southern hemisphere or in a different part of the Earth to keep getting the same data. It wouldn't have actually been Australia. They would have needed someone in China or some other place in the northern hemisphere. But yeah, potentially they could have used something in the southern hemisphere close to the equator. I'm not sure that Australia would have actually worked for Vega. But anyways, yeah, they definitely would have wanted to corroborate the data somehow with some other location. So anyway, so they did that. They know it's a sky-based source. They know they've got this audio signal, but then they're listening to the data later on, and that's when things start getting really interesting. That's a great face he's making right there. So there we go. So this is when they discovered that there are actual video images embedded into the signal. And as I mentioned earlier, it's the very first TV signal that was ever produced from Earth, which coincidentally happened to be Hitler. And so this is what gets national security in uproar because it's an image of Hitler. And they explain in the movie that it has absolutely nothing to do with Hitler. It's just the very first TV signal that left the Earth. And so it's just this intelligent form of life saying that we hear you. And they probably had no idea who Hitler was at the time and what was actually about to transpire during World War II. But it creates a big uproar. And then the signal gets even more complicated. They realized that embedded in each of the video frames, there's actually these three-dimensional layers of information. And that's where they actually get the plans to build the machine in these three-dimensional embedded layers in the video frames.
So that is plausible, the harmonics and the underlying
yeah, I mean, we can. I mean, like when you're downloading a video and an audio stream, from Amazon, you're getting both video and audio embedded in the same signal. And if you were only, if you had your screen turned off, you might still hear the sound through your speakers. Right. You might not even realize there was actual video that you were actually streaming.
Or a numerical depiction of a machine.
Sure. Yeah, and we can't embed 3D frames in video right now, but an advanced civilization might be able to do that. They might be able to embed all kinds of data into video in ways that we can't do that today. So yeah. Okay. Definitely science fiction right now, but perhaps that becomes science in 50 years or 100 years or 200 years.
Yeah.
So they get these plans for a long time. Nobody knows actually how to fit them all together. Oh, so here's a great image of the 3D nature of how all this was embedded. Each layer turns out to be a separate page of all the plans. And it looks like every 3 or 4 pages should fit together. but everyone's having a really hard time figuring out how to get these little diagrams in the corner of all the pages to match up. They can only get 3 out of the 4 pages to match. And then finally somebody realizes that they don't actually match up 2-dimensionally, they actually match up 3-dimensionally.
That was that guy, her benefactor, Haddon, that figured it out.
Haddon, yeah. So basically Haddon's character is modeled after Arthur C. Clarke.
Oh.
Yeah.
Oh, it's like Elon Musk now. But,
yeah, today's Elon Musk, right? A century ago, or not a century ago, 50, 60 years ago would have been Arthur C. Clarke. But yeah, Elon Musk today, definitely.
I thought it was Armand Hammer.
What's that?
There was a really rich guy named Armand Hammer who lived in his plane. He never touched down except to refuel, just like this guy.
Yep, there you go. So yeah, so he figures out that each 3 or 4 images actually match up 3-dimensionally to make these cubes of information. And then they realize that it's actually plans to build a machine, and things go nuts at that point. And this is where the film really takes a political turn, right? So they start talking about all the geopolitics involved in actually discovering a signal from outer space. You know, how governments respond to it, how, you know, kind of cult alien believers respond to it, and all kinds of folks. Eventually, they decide to build the machine, and see if I can find a good screenshot of the machine itself, because it actually has some historical significance.
Ooh.
And I didn't know this until
they superimpose it on Cocoa Beach, which is very cool.
Yeah, isn't that fun?
Yeah.
So there's
next to the what do you call that? The large building where they build the space shuttle.
The assembly.
Yeah.
Yeah. That's they show that in the background with this gigantic thing in the foreground.
Yeah. Oh, I just passed it. Okay, there we go.
Yeah, right there.
Okay. So
and there it is. You can see in the back on the left. That small building is the assembly building back there.
Yeah. So several really interesting things about this machine. It's hard to see here, but it's basically a sphere encapsulated in a dodecahedron. And the significance there is that the ancient Greeks had this belief in the sacred solids, dodecahedron being one of them. And the dodecahedron was supposed to symbolize the structure of the universe. And so kind of a cool addition of Carl Sagan's to use that as the shape that would open up a wormhole to travel through the universe. So that's the significance of the inner part of this machine. And so just a few words of commentary on the machine, right? So it's an alien machine. They're, you know, incredibly more advanced than we are. So somehow they've figured out how to create a device that opens up a wormhole. But it seems odd to me that we're able to construct the same machine with earthly materials. That doesn't seem to work. They make it work in the movie, but you'd think such radically advanced technology would probably require something more than just the standard metals that you know, a 19th century, 20th century civilization would be able to manufacture. Especially when they actually start the machine up and the door mysteriously melds into the rest of the machine. Are we really to believe that we can do that with a few wires and fancy technology? Let me bring up that scene for you. This is the part that's pretty unbelievable for me in terms of even if we did get plans to build such a device, this is something that we could never actually engineer. Just about there.
Well, the metals elsewhere, would they are you thinking that there would be different elements in
no,
other?
the elements are the same everywhere.
Right,
But
yeah.
figuring out how to manipulate them in the way we're about to see is probably not something that's ever going to happen on Earth. I mean, we're talking about like, melting temperatures of metals. So yeah, could you construct something like this out of a metal that melts at room temperature, like mercury? Yeah, but that has other drawbacks to it. Let me see if I can, oh yeah, I think this is actually it right here. So yeah, let's just watch this little sequence so you can see this door miraculously just fuse into the rest of the machine. Here it comes. Pretty sweet. I mean, I don't think that was really necessary. And, I can believe that aliens might send us designs to build some kind of a machine that opens up a wormhole. Seems like a nice gesture of goodwill, but it would have to be feasible with the technology that we have. So even if we designed something using their incredibly advanced designs, we'd still be designing it with our materials, and it couldn't do anything out of the realm of physics that we actually know of on Earth. So you wouldn't have a door melding into the rest of the structure like that. The other thing that kind of gets me about how this machine actually works is we're supposed to believe that these fast rotating beams somehow open up a wormhole. Well, I'll just bring it up to that sequence where the machine is supposedly starting to open up a wormhole by how fast it's all spinning. I think this is a good picture of it here. Let me just play a short sequence so you can see this.
80%. All vibration and G levels are in the green.
There you go. Okay, so I don't care how fast you spin anything. It's not going to open up a wormhole. So, I mean, maybe we do figure out how to manipulate the fabric of space-time and actually create wormholes at some point in our future. Maybe some intelligent form of life somewhere out in the Milky Way or in other galaxies has already done that. But it's not going to be by spinning these beams around each other. It's going to create a lot of friction and a lot of heat, but it's not going to create a rip in space-time to open up a wormhole. We'd actually have to figure out some way of literally, ripping space and moving it, and it's not going to be from kinetic energy and friction as they depict here. It looks really cool, but that's not going to be the way we open up a wormhole. So that brings us to this individual wormhole and actually the whole series of wormholes that the character Ellie Airway travels through. And so in the movie, it takes her 18 hours to travel through all these wormholes, come in contact with one of these aliens who shows up in the form of her deceased father, and then to travel back to Earth in the reverse direction in the same wormholes. So potentially wormholes exist, as we talked about last time, even though we've never seen matter with negative mass, which would be necessary to create these wormholes, but maybe it exists out there in the universe and we figure out how to manipulate it at some point. And sure, some time will elapse if we travel through wormholes. In the movie, she appears to completely skip the wormholes from the perspective of observers on Earth. So you see this instantaneous fall that she makes right through the mouth of the wormhole into the safety nets at the base of the machine. as if she didn't go anywhere. And so it leads to this huge controversy that she didn't actually go anywhere. It's just this big conspiracy by H.R. Haddon, her benefactor, and her. So that actually is plausible. Wormholes could actually work that way. You could go into a wormhole and come out of it simultaneously with respect to observers on one side of the wormhole. No time could elapse for them during any time that you spend in the wormhole. We talked briefly about time paradoxes last time, and that's one of the problems with wormholes, which may render them impossible. But yeah, you could potentially spend days, years, decades traveling through wormholes to different parts of the universe, but come back out the place that you came in instantaneously. That's totally possible. And that's just the very strange nature of traveling through wormholes. They don't follow the same causal relationships of space and time as traveling, directly through space and time does. So that part was kind of cool. I really like that part of the movie. But yeah, it leads to this big controversy about whether or not she actually traveled. But there's this evidence of 18 hours of static recorded by her device that you can actually see that she's wearing right there in that frame, which doesn't jibe with her actually having this, momentary trip into the safety net. So seems like she really did travel for 18 hours somewhere, even though there's no way of actually reading the recording. That part I'm not so sure about. I don't see any reason why her recording device wouldn't work. It's not experiencing any strange acceleration different than what she's experiencing, so it should be recording just fine. And when it actually gets brought back into the lab, I don't see any reason why it wouldn't have actually seen everything that she saw if it had a camera and some kind of audio device to record the audio, microphone. So
unless they jammed it on purpose.
Unless they jammed it on purpose, and maybe the aliens wanted it to be like that, but they explained to her that it's this first giant step in communication. So you think they'd want people to know for sure, and yet they withhold that information. So who knows what's going on with that?
Well, I guess you can make the argument that if you're going through a wormhole, since we don't know of any wormholes to test this on, so you can say whatever you want.
Yeah.
Up the radio, it's going to screw up the recording somehow.
Yeah, and we may find out when we construct our first wormhole that we can't get any recordings in it. I'll eat my words if that's actually what happens. So that those are kind of the big parts of this movie.
Why do you think the I felt watching her go through these wormholes like it was watching somebody transfer at 3 or 4 subways in New York City or something?
Yeah.
Why did they add that element that instead of one wormhole, she starts and she ends up in Vega? Why they added the 2 or 3 stations that she had to go to?
Yeah, it's a great question. I'll be honest and say that I've actually never read the book Contact, so I don't know if it's the same that was depicted in the book. My sense is that it makes for just a slightly more fantastic journey. In Stargate, they travel just through one wormhole, and it's a big flash of light, and then they're there on the alien world. So yeah, as you put it, having her do several subway stops on different wormholes extends the journey a little bit and makes it a bit more cinematically pleasing. But yeah, unnecessary. There could have just been one wormhole right from Earth to Vega.
That scene always gets to me too, because I feel like it's really exaggerated. Like she's just like like really uncomfortably getting jostled in her thing.
Yeah, and my guess is that wouldn't happen in a wormhole.
Right, like she's getting like gravitationally pulled.
Yeah. My guess is you wouldn't feel any force at all. You're not actually traveling through space. You're not actually accelerating or decelerating, I think you'd probably be weightless, actually, as she does appear in one segment when it finally comes to rest. And I do want to show you one other segment when she arrives on this alien world, right here. She sees this like incredible cosmic event taking place. It's just a computer-generated image, somehow downloaded into her brain because she reaches out and touches it and it kind of vibrates. See if I can find, oh, there it is. That's actually the one I wanted to show you. See if I can get it right here. Oh, people are howling outside my window right now. It's the 8 o'clock howl.
Oh, is it 8?
Yeah. Let me bring up the scene of this celestial event.
To describe it.
This is when she talks about they should have sent a poet.
Poetry. They should have sent a poet. So beautiful.
We're going to get to see it here in a second.
So beautiful.
Maybe we already missed it.
So beautiful.
No. Oh.
I had no idea.
Oh.
I had no idea. I had no idea.
Yeah, I think we missed it.
I had no.
I'll go back to it.
No. Coming up.
Is it coming up here?
Yeah.
No, this is the other scene. This is the Pensacola scene. Yeah, I want to go back to this other one.
When she first lands and then she reaches out.
Oh yeah, you're right. Here it comes. Sorry, my bad.
I don't understand why you might not feel deceleration in a wormhole.
I think because it's out of space and time.
I had no idea.
Oh, see, we missed it again.
No,
It's right here. No, it's back beyond us. Yeah, she's already touching it. See, it's back a little bit.
I thought that.
I want to show you this other one. This like incredible celestial event that she sees. Right there.
Oh.
All right, I think it's going to come up in a few seconds. It's, I think, one of the coolest celestial scenes that we get in the whole film. I have no idea what it is. Here it comes. Right here. Okay, so it looks like she's either looking into a star that's forming. So it's got this big accretion disk around it where perhaps like 2 planets have already formed farther away from the star. And then there's this big field of debris that's still coalescing into other planets. Or somehow it's like superimposed like an entire galaxy and you're just seeing these planets in the foreground. I'm not really sure what we're looking at here, but those are my 2 guesses. Yeah, I'll play it so you can see it for a sec.
Some celestial event.
Yeah. So we only get to see it for a few seconds, but yeah, it seems to be like part galaxy, part solar system. So we are at 8 o'clock. I just wanted to show you a couple images of the real life Ellie Airway, who happens to be Jill Tarter, the founder of SETI, a collaborator with Carl Sagan and several other notable astronomers, and the telescopes that SETI actually uses to search for extraterrestrial life. I'll bring up her picture here. So that's Jill. It was such a pleasure to hang out with her a couple of years ago when she came and spoke for the Science Speaker Series. I have to say that in the 3 years we've done the Science Speaker Series, my favorite few moments in the whole shebang were about 15 or 20 minutes that I sat backstage with Jill Tarter and just chatted with her while she ate a burrito that I made for her. That was a lot of fun. And then I also want to show you what the telescopes look like that SETI uses. I'll bring those up. So this is what the telescopes that most commonly get used by SETI look like. Almost look like, like 1980s, 1990s TV dishes, but they've got this like weird horn attached to them. And I guess the story is that that increases the sensitivity at exactly the frequencies that SETI thinks are most likely to be broadcast by intelligent life forms. And so, yeah, these are telescopes dedicated to the search for extraterrestrial life. And so not only are we looking for signals using these types of telescopes, they're actually a group of astronomers who are sending signals that have a better chance of being received. Very concentrated, high amplitude signals that have a much better chance of being picked up over dozens of light years, as opposed to the typical radio and TV signals that leave Earth just because they're being produced on Earth, which get so diffuse that it's probably going to be impossible for anybody other than incredibly intelligent civilizations to pick up. So we are actually sending signals, controversially. Some people think it's a bad idea because who knows who we're going to contact. But yeah, one of the ways that we're hoping to come in contact with intelligent forms of life.
What kind of hardware like sends those concentrated signals out?
It's a great question. I don't think it's that dissimilar from the same type of technology that broadcasts radio, a typical, like radio and TV. They're just much more powerful, and so the signal's a lot stronger. But I don't think it's radically different technology.
Yeah.
What's with the frequency? You said specifically chosen frequencies that are more likely to be listened to. Heard. What's
I meant to look back at the slideshow that Jill did, because she discussed that a little bit, and I forgot to do so. I know that there's a range of frequencies that that SETI scientists feel pretty comfortable saying is the most likely signal that they'll receive, but I don't remember the details and the rationale behind that.
Yeah, that would.
But I'll look that up and send it to you in an email, Deb.
Thanks very much.
Yeah,
that's interesting. Yeah.
Yeah. Any other questions or comments about this stuff?
Well, just to stay with the alien issue that we're going to touch on for a second. I mean, I think they do make a comment in the movie, the same issue that you touched on about, are the aliens going to be good or bad?
Right.
Whole dialogue that's the last 2 decades since that movie has gotten expanded, with Stephen Hawking as a proponent for one side, we better continue to hide out, and not let anybody know we're here.
That's right.
Versus clearly Carl Sagan, in the vision. I mean, it was these wonderful aliens that, to Jodie Foster, I guess Joe Arroway saying, no, we've done, this is the way, we can't give you any more now because we've done this time and time again, and we have a formula for introducing growing civilizations into the cosmic brotherhood or sisterhood or whatever,
right?
The connectedness, and that it's one step at a time.
Yeah.
This is it for now.
Yeah.
So, you know, I mean, it was very nice. And, you know, obviously the idea that, you know, the alien takes on a form of the person she loves the most, her father, rather than have her to deal with anything uncomfortable in that way, is very loving, you know. And so it's the positive side of alienness that, you know, in that whole continuum that we struggle with now.
Yeah, and the interesting thing is there are very few sci-fi movies that only depict the kind, you know, compassionate, understanding, patient aliens. In most sci-fi films and series, we get a mix of both. But yeah, they're only good. Although they're not all-knowing. They admit that they don't understand or even know who laid down the wormholes. They were set by civilizations that are long gone, and so they don't have all the answers.
I guess that gives a sense of eternity, of gigantic scope that they didn't know about this, and vastness, just like the vastness at the beginning. You know, with the astronomical vastness, this is a psychological, extraterrestrial vastness.
Yeah, you know, with a 14 billion year old universe, there's a lot of opportunity for civilizations to be radically advanced. So this gets into the Fermi Paradox.
Which is?
The Fermi Paradox basically suggests, well, if there's intelligent life all over the universe, like so many of us would like to believe, why haven't we come in contact with that life yet?
Where's everybody?
What's that?
Where is everybody?
Where is everybody? Yeah, that's the Fermi Paradox in a nutshell. So Enrico Fermi was a physicist, contemporary of Einstein, who basically did a little thought experiment and laid out 10 different explanations of why we haven't come in contact with anybody. You know, everything from we truly are alone, they're just not there, to we're just too primitive and they're not interested in contacting us yet. We've got to reach some kind of technological prowess before any, you know, sufficiently advanced technology or technological civilization is even interested in chatting with us. So yeah, the Fermi Paradox is fascinating. I actually did a segment on that in a class that I taught at the community school last year. It was a lot of fun. But yeah, that question remains to be answered. My guess is in, I would say 20 years, we're going to have confirmation of life on some other body in the solar system.
Really? 20 years?
Yeah, my guess is 20 years, we're either going to have confirmation of microbes under the soil of Mars or on Europa, Io. We're gonna find some form of life in the solar system, microbial life probably. Within 30 years, I think, and maybe with 20, we'll actually have confirmation of life on a star system outside of the solar system. We'll detect life on one of the exosolar planets that have been discovered already or have yet to be discovered.
With all these biosignature methodologies.
Yeah, it'll either be biosignature or as Jill Tarter talked about in her talk, technosignatures. Something similar to what we saw in the movie Contact. Yeah, so biosignatures would be atmospheres rich in oxygen and methane, right? So we're looking for something similar to our atmosphere. Oxygen rich for photosynthesis and methane rich from
cows.
Yeah, exactly. from farts or from decomposition. Yep.
Cyanobacteria in cows.
That's right. Yeah, everything from bacteria to cows. So those would be biosignatures, and then technosignatures would be, you know, something like in Contact. Probably not that extreme. You know, maybe we find some weird radio broadcasts or TV broadcasts without, you know, instructions to build a machine that opens up a wormhole, but enough to know that somebody's sending signals. Any other questions or comments before we close?
What's
Do you
the
know if
movie
there's
next
any?
week?
Go ahead.
Oh, sorry. Go ahead, Heather, and then we'll get Deb.
Yeah.
I was wondering if there's any, if you know of any information or messages that might be being transmitted in those signals that are being sent out. That we're sending out.
I don't know, but I know they've got that information on the SETI website. Yeah, so if you go to SETI, I think it's either SETI.com or SETI.org, SETI. You can look up information about the signals that are being sent out. Great question.
Yeah.
Oh, that reminds me.
Voyager
So
also.
the image that you see in this movie of like the humanoid figure with crossed legs inside the plans for the machine, that's actually a depiction of a similar image from one of the Pioneer spacecraft. That similar image of a human sitting cross-legged was sent out on one of the Pioneer spacecraft, 1970s. Yeah. Go for it, Deb.
Oh, what's the movie next week?
Oh, great question. I haven't picked it yet. We were thinking about Spaceballs.
Yeah. And you mentioned the Stargates, which I remember a little bit of the series, but.
Yeah, there's, I was thinking about Stargate as well. Unfortunately, there's just not that much science in Stargate, right? They've got a wormhole, but they really don't go into really much science at all. They've got an atomic bomb, and they've got this wormhole, but they don't really go into much about like how it got created, other than this like special metal that they have there. So yeah, well, I mean, we could do it. Spaceballs, Stargate. Any other ideas?
Stuart?
Someone suggested Ant-Man this past weekend to you.
Oh, that's right. Yeah, so
Prometheus.
What's that, Stuart?
I just said Prometheus.
Oh,
but maybe there's not science.
Yeah, Ant-Man versus the Wasp would be interesting because they get into some cool quantum mechanics stuff.
Okay.
That might be fun.
Are you gonna pick a movie and then let us know so you can watch it?
Yeah, I'll pick one in the next couple days and I'll let you know.
Great.
Cool. Well, thank you guys so much for joining me again tonight. It's been a lot of fun.
Thank you,
Sam.
Yeah, have a good evening.
Be well.
Good night.
See you guys.
Good night.
Night, Stuart.
See you, Deb. See you, everybody.